calculus, let's just use it. We'll go through the long way, and then I'll just talk about, hopefully, that you see what happens so that we don't have to do that anymore, okay? All right, so what happens here? I'm going to integrate and then differentiate to compare. If I integrated this in terms of t, wouldn't I get t plus t cubed over 3? And then I do it from x to 0. So what would that give me? X plus x cubed over 3 minus 0. Because I had to do this minus this, right? Okay. If I then asked you to take the derivative of this, what's the derivative of x? 1, right? What's the derivative of this? 3x squared divided by 3, so it would just be x squared. Do you see by taking this long process, what happens is I got the original function back, but not with a t, rather an x.
That's all this is?
Mm-hmm.
It seems so easy, but I don't understand.
Okay, so basically, I mean, I don't want you to do it the long way, though, okay?
You basically want to look at a function.
Yeah, if I said to you, okay, so I'm telling you this is the antiderivative, okay, f. I want you to find f prime of x. So what I'm going to do then is I'm going to use the fundamental theorem of calculus. According to what we just said, f prime of x means I'm taking the derivative of x over 2, the square root of 1 plus 2t dt. What the fundamental theorem of calculus says is if I take the derivative of, as long as it's x to a number, I don't have to go through that whole process. What should it just be? Exactly. Now, actually at this point you wouldn't even know how to antiderive that and put it back. Okay?
Wait, we wouldn't know how to do the antiderivative.
No. Okay.
So it gave us the derivative and we basically...
I asked you to find this. So I was just asking you to take the derivative of both sides. And then you'd have to use the fundamental theorem of calculus.
So that's an interval. That's the next one? The first step. Like right by the number 2.
I'm asking you to find f prime, the capital F prime of x. Okay? Uh-oh.
I thought the capital F or whatever meant derivative. So that's confused, like we started.
Capital F means antiderivative.
So capital F prime.
So what this means is, take the antiderivative, then take the derivative, you get the original function.
Think about it, the antiderivative.
If this means antiderivative, right? If that means the antiderivative, and then I ask you to take the derivative, isn't that the same thing as asking you to tell me what the function is? Yeah. Okay?
Oh yeah.
All right. What if I have something different on top? Well, first of all, guys, you can use it. Let's say it was flipped around and there was a 2 on top and an x on the bottom. What have we learned before that we could do? Just make it negative, then you can still apply the rule, the canceling rule, okay? But what if there is something other than just a plain old x? Okay. No, you just have to remember chain rule. Chain rule. So if I would, let's say I would use a different letter. Let's say I would say u to 3 cosine t, or cosine u du, okay? And they asked you to do the derivative of that, you would say that if I had the derivative and then the antiderivative, it would just cancel, correct? But if I said let u equal x squared, then what is the derivative? 2x. And so what I have to make sure I do is if it's something other than x squared, that I can still use the canceling thing, but then I have to make sure I multiply by the du, okay? Or in this case, the dt. All right, so this is going to be okay. So according to what we said there, it's going to be f of x. So really what I'm saying is it's f of x dx. Okay? So that would be, what's the antiderivative? Oh, I'm sorry. I'm not going to do the long way. I'm going to do the shortcut. If I have an antiderivative and then I take the derivative, those cancel one another out. So it should be cosine of, what is this? X squared, but then I have to multiply by 2x. Okay, what's the problem with this one? There, on the bottom, it's not a constant, right? So we're going to use some of the properties we learned before to write it as a constant. Couldn't I write this as from 0 to 3x t squared plus 1 dt minus 0 to 2x t squared plus 1 dt. Do you remember that from before? Okay. And that's basically just a kind of a, just using a property that we already know, and then it just allows us to use it. Okay. We have to do chain rule again. What's the derivative of 3x? Just 3, and the derivative of 2x is just 2. Okay. But we can still use this rule, okay? So, again, all of the instructions here had, this is still my instruction, find f prime of x, okay? So this is what f of x equals.
I don't get why you put the thing in front.
What thing in front?
Like, for the last one, you put 2x in front.
Because this is, so this really means, this is f of x, this really means there should be a dx there, okay? Dx just happens to be 1 here, because what's the derivative of x? 1. However, if it's not a 1, you have to multiply by what the derivative is, okay? Mm-hmm. So if I asked you to do the derivative of these things, that's like asking you to take the derivative of this integral and the derivative of that integral. What do a derivative and an integral do? They cancel each other out, but we have to keep in mind chain rule, okay? So this part, instead of t squared, I would write 3x squared plus 1, but then I'm going to multiply the whole thing by 3. Okay, so that instead of t squared, 3x parentheses squared plus 1, going to multiply the whole thing by 3. What would happen over here? 2x parentheses squared plus 1, and then I'm going to multiply that whole thing by 2. All right, let's see if we can simplify it. So what's 3x squared? That's 3x times 3x. Isn't that 9x squared? Okay. So let's see. If I distributed that 3 out, that would be 27x squared plus 3 for this parentheses. Because 3x squared is 9x squared. Now distribute the 3. 3 times 9x squared is 27x squared plus 3. I'm doing order of operations. What's 2x parentheses squared? 4x squared. Distribute the 2. This would be minus 8x squared plus 2. But I'm subtracting this whole thing. What's 27 minus 8? So this would be 19x squared plus 1 is what f prime of x equals. I'm sorry. I should say capital F prime of x equals.
Yeah, well, like, what is this for? I don't get what this is for, like, what does this mean even?
Like, what can you use this for, or?
You don't understand that a derivative of an integral in some ways cancels each other out because we're using an antiderivative.
I mean, I get it.
Okay.
I guess. I just don't get why we would use it.
Well, it's important to understand that concept because now when we look at graphs, like on Monday, that if I asked you to find the slope of something, that you're understanding, oh, I can just use the function to find the slope. That you will understand, like, because there's an integral in front, finding the derivative of that really just says that the derivative becomes the function. Okay? All right. I mean, I don't want to go any more into it than that because I think you'll see what I'm saying when we look at graphs. I was alluding to this before. When this is not chain rule, but the x is at the bottom. And so what I would do before I started this problem is I would rewrite this as negative x to 5 3t sine t dt. Are you guys all okay with that?
Oh, wait.
This is a rule that we learned about with reversing the endpoints of integration from earlier on. Again, that allows me to use the fundamental theorem of calculus to cancel the integral out. But then I just make sure, so if I said now take the derivative of this I'd write this way. The derivative of this is going to cancel out, the integral and derivative cancel each other out, but that negative is still in front. So this would be negative 3x sine x. And this is dx, which is just 1. So I don't write it down. You mean by doing it the long way?
Like,
That would be